Okay, more impulse practice problems. So, in this problem, we have a 0.6 kilogram air track glider colliding with a spring. So, just some object is bouncing off a spring. We have a mass of that object of 0.6 kilograms. And it's going to bounce off the spring such that it has this velocity versus time graph. So this is 0, this is -3, and this is +3. It's going to come in with -3 and then go to +3, which yields a force versus time graph. So we have a triangle with an unknown delta t and a maximum force of 36 newtons. And this velocity versus time graph is in meters per second. So, the figures show the glider's velocity and force exerted on the glider by the spring. How long is the glider in contact with the spring? So the goal of this problem is to find delta t. So, we need to use our impulse equation, which is F delta t, or area under force versus time graph. So our area is equal to 1/2 base times height, which is 1/2 delta t, which is our unknown, times our height, which is 36 newtons. So this is just 36 divided by 2, so this is 18 delta t. So our impulse is 18 delta t. So the other part of our equation for impulse is equal to the change in the momentum. So that is equal to Pf minus Pi, which is equal to mvf minus mvi. So if we look at our graph for velocity, our initial velocity, this means that vi is equal to -3 and Vf is equal to 3. So that means our mass is also 0.6. So 0.6 times 3 minus 0.6 times -3. So this is 0.6 times 3, 1.8 plus negative times a negative is positive, 1.8, which is equal to 3.6 newtons times seconds. So we used our two equations. They are equal to each other. So this is J here, and this is J here. So we have to set these equal to each other. 18 delta t is equal to 3.6. Divide both sides by 18. We get that delta t is equal to 0.2 seconds.